this assessment, we're asked to consider why a nucleophilic addition elimination process will happen with carboxylic acids and carboxylic acid derivatives, but we didn't consider it in the context of aldehydes and ketones. And I think it's important that we answer this question because organic chemistry is about learning how the same thing repeats over and over again. So it's fair to ask this question: when we added strong nucleophiles to aldehydes and ketones, why didn't it undergo the elimination? Well, let's think about on screen what would have had to happen. So we've added a methyl group from the Grignard reagent to make what we're going to consider for this problem a tetrahedral intermediate. Well, in order for this to go on and do the elimination, these electrons would have to collapse down and kick out H minus. I hope you're cringing at home when you see that, because what do we know about H minus? It is very unstable. The fact that it's so unstable is exactly why this does not undergo the elimination, and all the other carboxylic acid derivatives do. The carboxylic acid derivatives are going to have a chloride, an oxygen, a nitrogen, things that can stabilize that negative charge far, far better than H minus can. If we look at the pKa of the conjugate acid of H minus, you're talking about H2, its pKa is higher than 35. I think the number 42 comes to mind. But this is a really, really unstable anion, a very, very, very poor leaving group. In fact, we should think of it as not even a leaving group at all. And so for that reason, the only thing that happens with aldehydes and ketones is the nucleophilic addition. When we have a group here that's a good leaving group, as is the case in the carboxylic acid derivatives, the elimination step happens.